Hi, everyone. Welcome to the Unit 4 review. This is going to be the second version. So this is the number 2. And this can be found in your Canvas page for today's date. All right, so for number 2, again, we're just going to be simplifying. And we take a look at this as a 252. Use this way this time. I'll kind of go back and forth. So what goes into 252? I'm like, well, 2 is even. So 2 goes into 25. Actually, let's go 2 goes into 2. 2 goes into 2 once. 2 goes into 5 2 times. Remainder of 1. 2 goes into 12 6 times. Or put in your calculator. Either way is okay. We're going to just keep on going. So what goes into 126? And that would be 2. So 2 goes into 126, let's see, 63 times. And just keep on going. Make sure you're pulling out only prime numbers, not composite numbers. Like composite numbers are like numbers that can be divisible by other numbers, right? Other than 1. So let's see here. So we're going to take out a 3. So 3 goes into 63 21 times. And I know 3 goes into that. 3 goes into 21 7 times. Just going to keep on going until we get to 1. All right, so now that we have the prime factorization, we're going to look for, well, let me just set this up. So I like to set it up. Here's my radical. And I have my 6 already out here. So here we go. I'm going to pull out. So it's a square root. So I'm looking for groups of 2 since there's nothing there, right? So I have a group of 2 here. So that's my times 2. And I have a group of 3 here. That's going to be times 3. So remember, this is just like 2 squared, right? Because 2 times 2 is 2 squared. And so remember, this is inside the square root, right? Like this. So remember, the square and the square root, they cancel each other out. And all we have left is a 2. That's why it's just 2. All right. And then same thing with the 3. We got 2 of those. So which would be 3 squared. We're square rooting that. So all we have left is a 3. Now, and notice right here, 7 is the only thing left over. Yes, technically 1, but 7 times 1 is what? 7. So we're just going to write 7 in there. Now we're going to deal with our variables. So if you notice right here, let's use orange. So x to the 4th, what I like to do is you just, since it's our index is 2, right? So it's just, we want, how many 2's go into 4? It's basically just division, right? 4 divided by 2, which is x squared. And then same thing here, y of the 4 divided by 2. So we have y, haha, not inside. What am I doing? Sad days. Okay, so that should be x squared on the outside and then y squared on the outside. Yike-a-rambas. If you like to write them out, so there would be 4 x's and then we have 2 groups of x's. Same thing with the y's, would be 2 groups for the y's. So notice that there's nothing else in here. So I'm going to just make this a little bit nicer because this looks a bit of a mess. So 2 times 3 is 6. 6 times 6 is 36. And this is going to be x squared, y squared, and the square root of 7. And notice, okay, we got to think about it because remember it says use absolute value signs when necessary. And x squared will always be positive and y squared will always be positive. So while you could put in absolute values, you don't have to. It's redundant. So you can just leave it like this. There we go. And you would only have to worry about absolute value signs only with odd roots. So only with, like, if you're doing a cube root. Did I say odd roots? That didn't happen. You're like, that's not right. Only with even roots. Only with even roots. Okay, so that's when you would have to think about, okay, do I need absolute value signs? Because always with like square roots or 4th roots, the answer always has to end up being positive. So here we go. So if you look at number 2, let's try this again. So this time I'm going to do a factor tree. So I know that 4 goes into 128. So 4 goes into 12 3 times. 4 goes into 8 2 times. I'm just going to keep on going. And this is to the 5th root. And honestly, I don't know my perfect fifths. So therefore, I'm going to just do my prime factorization. So that's going to be 8 times 4, right? 8 times 4. And then 8 is 4 times 2. And this is going to be 2 times 2. This is 2 times 2. Just make sure yeah, that you multiply these. Remember, this is all multiplying, not adding. So, all right, so we're looking for groups of 5 here, right? So a group of 5, before I talk about my groups of 5, let me set this up. So I have my 5th root. I'm gonna put lots of room. Here's my 4, see this 4 right out here? That's this 4 right here. And I'm gonna this is where I'm gonna put like things go in or out. So now let's take a look here. So groups of 5 here. So I got 1, 2, 3, 4, and then 5. A backward J, right? So this is gonna be 2 to the 5th power, right? And remember, we're doing it to the 5th root, right? So they're gonna cancel out. So all we have left is just a 2 on the outside. So it's just 2. It makes it out. And then right here, we have these 2 left over. So that's 2 times 2, which is gonna be the 4. Okay, so this goes right there. Okay, and these 2's goes right there. All right, so now we're gonna take we dealt with the 128. Now we're gonna do with the X and the Y. So remember, we have 8 X's, right? So again, you can think of it like divide, because it is divide. So how many 5s can we take out of 8? So 8 divided by 5 is 1, right? There's 1 that we could take out. And then what do you have left over? Well, you would have 3 left over, right? So that would be X cubed. Visually, what that would look like is, oh, there's one group of 5, and how many have left over? Those 3 right here. All right. And then same thing with the Y. So if we have 6 Ys, how many groups of 5 can we take out? We take out 1 group. So there's Y, and then we have 1 Y left over, right? So this is a group of 5, and then the 1 left over. There we go, just like that. So I'm gonna make this a little bit nicer. So this is gonna be 4 times 2, so 8xy, 5th root of 4x cubed y. Oh, do we need to absolute values? Because remember, we only have to do with even roots, so we don't have to worry about with the odd ones. Remember, if you remember way back in the day, they did not have domain restrictions. So we're good. Phew. All right, so this video should be not so long, hopefully. All right, so we're going to continue on. Here we go, 80. And I know this is going to be 8 times 10. And this is going to be 4 times 2. And 4 is 2 times 2. Again, please make sure that you stop, or you pause, and then you do it yourself, right? And then press play. Okay, and if you need a little bit of hand, you're like, okay, what's my first step? Then press play for a little bit. Go, oh, that's my first step, and then press pause, and then go on. All right, and then 10 is going to be 5 times 2, and everything are prime numbers, so we're good to go. And again, this is a square root, so we're looking for groups of 2. And I'm just going to set this up really quick. Got my square root, got my 4 out here because that guy is already out here. So here's one group, and so that's going to be times 2. And here's another group, and that's another times 2. And honestly, if you're like, okay, Miss Lee, can I just write multiply by 4? Like, yeah, you totally can. I'm just trying to be more specific. And our leftover guy, don't forget the 5, and that stays in here because the square root of 5 is not a perfect square, so it just stays inside. And then we got our x's. We have 3 x's, so that's going to be 1 x here, one group of 2, right? And then we have 1 left over. Okay, again, for those who are visual, that guy here, left over there, right? And then for our y, it's going to be, what color? Okay, so y to the 4th, remember, so that's 2 groups that we have with no leftovers. So it's just going to be y squared. So here we go. So 2 times 2 is 4. 4 times 4 is 16. So it's going to be 16xy squared, square root of 5x. Absolute value? Absolutely. Right? But where? You would never put it around the number, okay? Because we need to leave 16 as 16, right? If this was a negative number, then we would leave it as a negative number. Just leave the numbers alone. It's just the variables. Could they be negative? So the answer, in other words, the answer. So the y squared will always be positive, right? Because it's a square. But the x has the potential to be negative. So we have to make sure that we have the absolute values there. If you put it around both variables, again, that's fine. I'm not going to count wrong. It's technically not wrong, right? But yeah, to be more specific, that's what it would look like. Boom, just like that. All right, take a look at number 4. And number 4 is going to be, let's see here. Got my square root right out here, -4. And we're gonna have, so 147. So that's gonna be 7 for sure, right? 7 goes into 14 2 times, 7 goes into 7 once. And that's gonna be, what goes into 21? 7 and 3. All right. So we got our 1 square root, so that's gonna be 7. Then our leftover right here is gonna be 3. And then we're gonna have, so that deals with the number. And the u is just u. There's only 1, so we can't make any groups of anything. So it's just u. And then v to the 3rd power, that as 3 v's. So that means we could take one group of 3 or one group of u out, and then we, did I say u? I meant v. So one group of v out, and then one v stays inside right here, that one. I usually use my fingers a lot. I don't know about you, but that's what I do. All right, so we're gonna clean this up. This is gonna be -28 v square root of 3uv. Do we need to put in absolute values? You thought I was gonna forget, huh? Not around the -28. Remember what I said about numbers, leave the numbers alone. But this v, yeah, has the potential to be negative, so we're just gonna go boop, just like that. All right, because remember, we are dealing with an even root. All right, enough of that. Now we're gonna go into simplifying, and you may notice, I don't know if it bothers you or not, but I did make a different version of this. Same problems, I just made more space so that when I'm doing this video, it will be, I'm not having to squish everything in. All right, so here we go. So that's why it may be in a different place on the paper for you, but don't worry about that. Still the same problems. Okay, when it says simplify, we're literally going to first do what we've been doing in 1 through 4, probably in a little bit smaller scale, because if you notice right here, we don't have as many variables. And then we're gonna combine like terms, if we can, as much as we can. So if I notice right here, 5 is a prime number. So it's not a perfect square, so we're just gonna leave that. So I'm just gonna copy, I'm gonna put this on the bottom here. So I'm gonna go 2 root 5m. And you may wonder, well, why are you putting it all the way down here? Because I'm trying to extend that so that I could do some of the work here. Okay, so I'm gonna put my simplified version down here, so I know it's gonna be minus whatever it is. All right, so let's take a look at this. So 45 is 9 and 5, and 9 is 3 and 3. So I know that this is my perfect square. So that's gonna be on the outside. Notice nothing is on the outside, so I'm just gonna put 3, and then square root of, what's left over is this m. All right, I mean 5, I saw the m, and then 5m. And m we cannot, is not a perfect square, so it just stays there, doing nothing, looking pretty. That's all it's got, okay? And then we're gonna go with the 54, so we know it's gonna be a minus, right? Because it says minus. And we're gonna do the same thing with 54. It's 9 times 6, right? And then 9 is gonna be 3 times 3, and 6 is 3 times 2. And if you notice, remember we need to have one group of, or groups of 2. So we have 1 right here and nothing else, right? So 3 times 3 is 9. So the square root of 9 is 3. And then the square root of, now these two, we have 2 numbers. What do you do with them? Just multiply them back. So 3 times 2, which is gonna be that 6. And again, the m, it's not a perfect square, so we're just leaving it inside the radical. It can't leave. So if you notice, what is my like terms? And some people are like, what do you mean? What are my like terms? Is it is the number in front? And no, it's just looking inside the radical. We're looking right here, just like this. So do you see how these are square root of 5m? And the green one is square root of 5m? Those are like terms. If you notice right here, the square root of 6m, yeah, that's not the same as 5m. So therefore, not like terms. Just like how we would do in regular like polynomials, right? With like 3x plus 2x squared. Yeah, you can't put those together because one of them is an x and the other one's an x squared. So here we go. 2 minus 3 is going to be -1. So this is just pretty much equal. I'm going to write the answer up here. Which is to negative square root of 5m minus 3 square root of 6m. And if you want to put in a 1, right in front, you can, right? But, you know, I already know that you know that it's just a 1, so, or technically -1, so we're good. All right. And again, that's, I don't know why that looks like an underscore. That's totally supposed to be a minus. There we go. Looks a little better. Number 6. Let's take a look here. Yeah, looks like I can definitely break this down. It's going to be 4 times 4. We know that 4 is 2 times 2 and 2 times 2. And so I have to have groups of 3. So I'm just going to put this right here. So my cube root, I already have a 3. So I need one group of 3, or not I need, I have one group of not 3, a group of, you know what I mean, a group of 3 for 2s. Okay, that's just getting confusing at this point. So that's gonna be 2. We got a group here of 2s, and then we have 1 left over, so that's gonna go and stay inside. And again, this P, not useful. Okay, we're just gonna leave it there because it's not a perfect cube. So beneath that, I'm just gonna simplify. So it's gonna be 6 cube root of 2p. And this one right here, 4, in my brain, I'm thinking, okay, it's just 2 times 2, right? That's all I have. I don't have a group of 3. So I'm just copying this down. There's nothing to simplify here. Makes my work easy. And the next one is going to be, okay, this, we have to do a little bit of work. So 108, I'm gonna ignore the negative for now, and then I'm gonna talk about it later. So 108 is definitely even. So I'm gonna go 2 times 54. And 54 is going to be 9 times 6. And this is 3 times 3 and 2 times 3. All right, we're going looking for groups of 3. All right, let's go. So here's my one group of 3. And actually, that's it. So it's going to be, here's my cube root and the 3 out in front. So this 3 is going to be right there. Notice there's 2 3s because one of them was already there. And then this 3 is that second one, just so that we're keeping track. And then what do we have left over is this 2 times 2. So 2 times 2, which is 4. All right, and then we're going to have this p there. Now I said we're going to deal with the negative. Now remember, if at all possible, take the negative out. Okay, if you can take it out of the radical, because it makes us a little uncomfortable. Negatives inside radicals, uncomfortable. So, and it's actually just standard procedure. It's usually what people do, right? So people meaning mathematicians. So what we're going to do is we're going to take that negative. We could either give it to the 3 or to the 4, right? So I told you we're going to give it to the 3. So if you want to think about it, so if I make these all negative, because remember they all have to be the same. So -3 times -3 times -3 is -27, right? And then we got the positive, so it's a negative times a positive, which we would still end up with a negative. So we're good to go. So that's going to be -3 right there. So I'm just going to add that to what we have. So remember that was a minus. But, oh, shoot, that's supposed to be a -9, which means that this is now going to be a +9, right? And then cube root of 4p. So remember that was a minus already, but now this is going to become -9. So minus a -9 is a +9. Just saying. And so do we have any like terms? Yes, you should have recognized, oh yeah, cube root of 4p. Those are the same. What's different? This one right here, so they don't go together. Oh, I probably shouldn't highlight all of that. It's like just this part that we really care about, not the coefficients. So our final answer is going to be 6 cube root of 2p and minus cube root of 4p plus 9 cube root of 4p is going to be, we're looking at just the numbers, so it's -1 plus 9, which is going to be plus 8 cube root of 4p. That's it. We're good to go. All right, we're on to number 7. I think a lot of people are pretty okay with these. Just remember to check for extraneous solutions. Remember, extraneous solutions mean, the answer that's not an answer. That. The solutions that's not a solution. Yeah, gotta check for that. So first step here, divide by -6. Again, please pause and do this first before, you have me just do it. And then the -6s are going to cancel out, and all we have left is -1 minus 50x And what do we do now? We're going to square both sides. And then what do we have left? So 7 squared is going to be 49, is equal to the square and the square root cancel out. So it's -1 minus 50x. And then what do we do? We're going to add 1. So this is like, brings us back to Algebra 1 memories, right? You're like, oh, if it was only that easy here. Well, look, it is that easy here. You're like -50x. And then now, how do we get rid of the -50? Divide -50, right? And so remember when you used to think this was so hard? Or maybe you always thought it was easy. I don't know. I honestly don't remember learning this stuff. It was just such a long time ago, I suppose. So 50 divided by -50 is going to be -1. And this is just going to be x. All right. I like to write it this way, x equal to -1. Now, but I'm not going to box it yet because I don't know if it's an answer. So we got to check it. So I'm going to put my check. Yeah, I should just put it right here in red. So here's my check. So plug this -1 back into the equation, the original equation. We got -42 is equal to -6 square root. Oh, we don't know, so put the question mark above there. -1 minus 50 times -1. All right. All we're going to do is we're going to leave the -52 alone. And we're going to simplify everything, keep everything on the right-hand side, or whatever the side that you're simplifying. All right. So what I'm going to do is order of operations. And so it's going to be -6 square root -1. And then -50 times -1 is going to be plus 50. And -6 square root of -1 plus 50 is 49. And what is the square root of 49? 7. Ooh, I forgot to put in my, is it equal to 42, -42? And don't stop here, go until you get to, yes, it's true. -42 is equal to -42. Happy days. So now I'm going to box it. Done. All right, next problem. First step, got to get rid of this 10. So subtract 10 on both sides. So that when I square the square root, I'm not going to have like craziness going on. So this will be -2 is equal to the square root of 3v. How do we get rid of that square root? By squaring it. So we're going to square root both sides, or square both sides, sorry. And then we're going to end up getting -2 squared, which is 4. And some of you guys may have noticed, you're like, wait, Miss Lee, didn't you say the square root can't equal negatives? Well, it is right here. I'm like, you're not wrong, right? And so if you notice that and you're like, oh, this is actually a no solution kind of thing, then explain to me why you believe that is true, okay? But if you're like, yeah, I can explain it, but I don't want to, I want to just do it algebraically, then do it algebraically. And this is what we're doing. So the square root and the square cancel out, so it's just 3v. And then you are going to divide both sides by 3. So your v should equal 4/3. I'm not going to box that yet, though, because we're going to see if it works. And you're like, fractions? I want fractions. Okay, it's not terrible. So 8, is that equal to square root of 3 times 4/3 plus 10? And if you notice, happy days, the 3's cancel out. So we didn't have to worry about it. We're good. So this is going to be 8. Is that equal to? What we have left is just 4 plus 10. And what is the square root of 4? 2 plus 10, which is going to be 8 is equal to 12. Yeah, that's not true. So that's definitely not equal to. This is not a solution. We would say no solution. That was an example of when the solution was not a solution. You are not you. What? All right, next one. Here we go. I'm just going to do a think aloud at this point, right? So I notice that this is going to be a square root. So there's only a square root there. So I'm going to just square both sides. And then we get 9 minus a is equal to 1 squared, which is 1. And then I'm going to subtract 9 on both sides. Now I have this negative a right here is equal to 1 minus 9, which is -8. Now I want to get rid of that negative. 2 ways to do it. I personally like to just multiply by -1. That's just me. You can divide by -1. It really doesn't matter. Because what is -1 times -1? Positive a, like +1, right? So this is just going to be a is equal to +8. And we're going to do our check. Hopefully that works. Pretty sure it does. 9 minus 8, is that equal to 1? This is a pretty easy check. That's going to be 1 is equal to, so the square root of 1 is 1 is equal to 1. Yes, now we can box it. This is definitely the solution. Happy days. Next one. All right, so before I square, I got to get rid of this -9 because that's not in the square root. I'm going to add 9 to both sides. And then I'm going to get, let's use this color. So the square root of n minus 4, or n over 4, is equal to 3. And I got to get rid of the square root now, so I'm going to square both sides. And I'm going to get n over 4 is equal to 3 squared, which is 9. We're so close. How to get rid of this divide by 9? Sometimes you need to say it out loud because a lot of people are like, oh, divide 4. Like, you just did that with your one. What? You can't do that. All right, so remember this is divide by 4. So you have to say to yourself, n divided by 4. Oh, multiply by 4. Yeah, that's a common mistake too. I see that all the day long. So n is equal to 36. So let's see if that's true. So here's my check. And so this is going to be the square root of 36 over 4 minus 9 is equal to -6, question mark. So I could just divide first, right? So 36 divided by 4 is square root of 9. Yeah, we're good. I was like, wait a minute, does this not work? Suppose it would be fine, but what's the square root of 9? 3. 3 minus 9, does that equal -6? Yes, it does. -6 is equal to -6. Happy days. Now I can box it. All right, there we go. So now let's try this out. This one is just writing from exponential form to radical form or radical form to exponential form. That's from 11 through 18. So these ones, again, they take no extra calculations. It's just, you're just rewriting it. That's all we're doing. So it's like changing a fraction to a decimal or a decimal to a fraction. You're just rewriting the way it looks. It's not actually anything different. So here we go. We needed this last time, so I'm going to just write it in here for you, just in case you didn't get it the first couple of times. So remember, our R is whatever's inside the radical, which we call the radicand. And this is our index. That tells us, is it a square root, a cube root, a fourth root, and what have you. So this is called radical form, obviously because there's a radical in there. And it could be written in exponential form this way. All right, so knowing that, let's try these out. So again, I'm gonna first start out with my K, and then it says to the power, so the power goes on top, and then the root goes on the bottom. That's it, done. One and done. All right, if they were only all this quick. So again, we have the 6v, so I'm gonna write in the 6v. And then we got my power. Now don't forget, you need to put parentheses in there because we want the 3 to go to both the 6 and the v, not just the v. All right. And then, oh, there's no number there, which means, what is it? Remember, it's called the square root. So think about, remember, it's related to the square. And what number is the square? 2. That's why this is an invisible 2 there. This 3 over 2. There we go. This one, same thing here. So we got 5x to the third power. Don't forget your parentheses. Over. This is square root, so it's going to be over 2. Okay, and don't get confused by this 1 over. It's like 1 over thing. Yeah, no worries about it. So we're just going to do as we normally have done. So this is going to be b, and again, exponent is 5 over 2 because it's just a square root. And since it's in the denominator instead of in the numerator where everything else is, just put a negative there. That's what the negative indicates. Just saying. All right, so then we're going to go the other way around. So I'm going to write my 6n again. And this time I'm going to put in my radical because we want it in radical form. And my root is going to go right here in the index area. And it's to the power of 1. So technically I can just leave it like that because those are all to the power of 1. Done. All right, and then the next one is going to, 16 is going to be Well, we'll do it just like how we did the other one. So 5n, and that goes inside the radical. And we know the root is 4. We want to the 4th power. So if I just put, just kidding, 5th power. And if I just put a 5 like that, that's only going to go to the end. So you need to make sure you put parentheses there. Okay. And now you're like, well, what about the negative? And now we're done. Just put it over 1, right? Or 1 over it, whatever it is, right? So this is that deals with that negative. All right. And then next one is going to be, again, 7a. Put in our radical. And then it's going to be square root. So I don't have to put a 2 there. Just leave it like that. That's going to be to the 3rd power. Now, I know in this this worksheet thing that I had made, it does the answer differently because the computer program does it that way. So what you can do is just put the parentheses around the whole thing and just cube that. Either way is okay. I will accept either answer. Either put the cube in the inside with the parentheses or put the parentheses on the outside and then put the cube outside that. Either way, it's fine. So here we got m to the 3rd power and then square root. Done. Yay. All right. Here is the fun part. All right, so let's take a look. Find the inverse, sketch the inverse graph by making an input-output table, and then identify the domain and range of both the function and the inverse. Okay, I know it's a lot, but it's okay. We'll just kind of deal with it as one by one. So first we're going to find the inverse. So over here on the left, I'm going to find the inverse. So I'm just copying this down. And if you know right here in class, I did not have it in there, but I put it in there for this one. The domain restrictions. In order to find the inverse of this function, you need to put in the restriction, or else when you remember when we invert it, it's like not a function, and that's sad days. You don't want that. So here we go. So these are assuming that all the x's are positive or 0. Okay, that kind of talks about our domain as well, right? Okay, so first step to find the inverse is first get out of this function notation. So instead of f of x, we're going to just plug in y. Don't ask why. I'm just kidding. And then here again, we're going to do the Freaky Friday, right? The x and the y switch, right? So it's going to be x over here and then y over here. It's crazy, right? And then from there, could you imagine if like that happened in real life? Your mom and dad switched places. What? That'd be too much. You're like, what? All right, so we're solving for y. What do we do first? So subtract 4 on both sides, right? Just treat x like how you would any number, because technically x is the number. Same with y, we just don't know what that number is. So it's going to be x minus 4 is equal to y squared. And how do we get rid of the square? The way we get rid of any square is you square root it. All right, and then so we're going to have, I'm just going to flip this, okay? So y is equal to square root of x minus 4. And some of you may have noticed, oh, why not the plus or minus? You know, because normally if we square root both sides, we have to do plus or minus. Remember what we said, that we were going to only look at the positive values, right? So we're only going to look at the positive ones, not the negative ones. All right. Now that we know that, so we're going to just change it back to our function notation. So we're going to say f, instead of saying f of x, because, you know, if we say f of x, it's referring to this f of x, and you're like, well, I don't know which one you're talking about, right? So we're going to be like, well, we need to look for inverses, right? So that we need to say this is the inverse. So we're going to just put in that -1 right there. So f -1 of f of x. We don't say that, we just say the inverse of f of x. All right. So step number 1, check. Found the inverse. Now we're going to graph it. All right, so graphing, we're just going to go like this, x, y. Remember radicals, think about what they look like in general. Remember, it's like half the parabola, so it's just like this, the parabola that fell down, actually twisted and fell down, right? So it's going to just be that top part like this. This is what we're looking for. So the question is, what is that beginning point, right? That beginning point, remember the smallest that this square root can be is 0. The whole square root can equal 0. So, but the question is, how do we get to that? So let's find out. So if we know, so what would x have to be? So we're going to do some detective work here. So I'm going to subtract it from with 4. And then what I want it to have is, actually, I'm going to put it right here. What I want it to have be is square root of 0, so that we just get 0. That's what I want. The question is, what is that number going to be? Right? Because what minus 4 is 0? And you're like, well, 4. Well, yes, 4 minus 4 is 0. So that means that we have to put in x equals to 4 so that we can get y equals 0. Here's 4, 0, just like that. And we're going to plot it right here. That's our starting point. Because anything after that, so I could put in like 2, right? But if I put 2 in for x, is 2 minus 4, which is -2. We can't have negative numbers in there inside the radical, because then that means it's imaginary. We can't graph imaginary. Not like this. So that's what we're looking for, this particular one. And then from here, we can just, I could just go one more up. So let's go with 5. So F5 is equal to. Now, please remember, you need to show your work. So please show your work as much as you can. Because if you're just graphing, you literally like go on Desmos and you just copy down the, like, I don't care if you can copy, like that doesn't help me with anything. You know how to just graph it by yourself, right? That's what I want to know. So I'm looking for this work. So if, yeah, that's what I want to know. So what is the square root of 5 minus 4? 5 minus 4 is 1, and the square root of 1 is 1. So here you go, that's 5, 1, just like that. And people have asked, well, how many points do we need? I'll tell you it's more than 2, because this looks like a linear problem, and we know it's definitely not linear. So honestly, if you're like, I don't know what other numbers to pick, just pick 6 then, right? It doesn't matter. And so if we do the square root of 6 minus 4, well, that's going to be 2. Well, like, what's the square root of 2? Use your calculator, right? You're going to go square root of 2. So it should look like this. So right there, 1.4. We don't need to get any more exact than that, just because, no, we're just graphing a thing. So it's going to be 6 and 1.4. So 6 and 1.4. Let's do a nice number. Let's do that color. So, sorry, I was like thinking. Well, what's another nice number? What if I could get it equal to 2? So this would be square root of 4. I was thinking, okay, so what minus 4 will give me a 4? Well, that has to be 8, right? 8 minus 4. So 8 minus 4 is going to be square root of 4, which I know is 2. I like these numbers, 8 and 2. So I always like to go the little extra step of like, okay, what number should I use that would make life easier for me? I'm always looking for how to make my life easier, right? So 8 and 2, just like that. Boom. So now we can kind of see where it's going. So I'm going to just stop here and I'm just going to graph it. We're just going to go boom, just like that. All right, so now we graphed it, done. Now we're going to identify the domain and the range. So let's do that. So the domain, so I'm going to go next to the function. And what is the domain for this function? And remember, we have domain restrictions, which means, because normally we could put anything for x. We could put negative numbers, positive numbers, it doesn't matter. But in this case, it does matter. Because we put in the restrictions, so it's just going to be smallest x can be a 0 all the way up to positive infinity. And then the range is going to be what? Well, what's the, if the domain, the smallest that x could be is 0, what's 0 squared? Well, that's 0. So 0 is the smallest number that x is going to be. So if we go 0 plus 4, that's 4. So 4 is going to be the smallest that y is going to ever be, right? You see how that we, see how the range is kind of depend on what the x is doing. So it's going to be from 4 up. That's what it's going to be. All right, and for the inverse, so we did it for the function. Now we have to do it for the inverse. For the inverse, I'm going to write it down over here. So for the domain, well, I have the graph here. So what is the domain? What the x is going to be, the smallest, the furthest left it's going to be is 4, right? So it goes from 4 all the way to positive. infinity, forever and ever in a day. And then the range, well, how low does it go? Goes all the way to 0 and higher. So it's going to be from 0 to infinity. And if you notice, like we've said before, our domains is our range, and our range is the domain. Remember, because why is that true? Because we flip them, remember? So that's why that's going to be true. All right, let's try the number 20. After this, we only have 4 more problems, so it's not terrible. Let's take a look here. So we're going to find the inverse. So this is going to be, I'm going to just change this to y is equal to x cubed over 2. I'm going to switch the x and the y, Freaky Friday. Now, before I cube root this, I'm going to get rid of that 2. So I'm going to multiply both sides by 2. And then what do I get is 2x is equal to y cubed. Now, how do we get rid of the cube now? Cube root it. So our answer is going to be y is equal to cube root of 2x. All right, and then that's pretty much it. There, remember, for the cubes, there are no restrictions, so we're good. This is already a function. We already know that. All right, we're just going to change this into function notation. There we go. And here's our answer right there. Now we got to graph it. So let's do our input-output table. Just draw a little line here. Draw a line in the sand. All right, so what number can I put in for x? Well, I can put in any number at this point, right? So I like to put in 0 because, you know. So for the inverse of f of x, if we put in a 0, that's going to be the cube root of 2 times 0. Well, 2 times 0 is just 0, so the whole thing is 0. All right, that makes it easy. Let's put that right there. Then let's try another point. Let's try 1, right? So f of -1 is 1. So 2 times 1. Oh, this doesn't give us a perfect cube, though, does it? Then that's going to be 2. Okay, we're just going to have to. Okay, what's the perfect cube? Oh, what's the cube root of 2? So we're going to go cube root of 2. So you should get something like that. So make sure you do the cube root right here like this, and then of 2, and then you get 1.2. Oh, actually 1.3-ish. All right, so about 1.3. So about 1.3. That's good enough. And then let's see, now it makes me wonder. Well, honestly, I mean, we could do the other side, right? So if we did -1, right? Well, the only thing that will change is that it's a negative number. So it's just going to be the cube root of -2, which would be -1.3. So let's do both of those. If it's a -1, it's -1.3. So -1, oh shoot, these are going by 2s. Why did I not see that? Anyways, this is going by 2, so -1 point, not, it's going to be -1.3, so like right about there. And this is going to be positive right about there. So if I stop here, because I got 3 dots, yeah, it's not going to be a very good graph. So I need to keep on going. So that's why I'm like, I can't give you like a set, like, well, you need to have at least 3, because in this case, if we did, it'd just be a straight line, and that's not helpful, right? Because we know it's not linear for sure. If you didn't know that, I don't know where you've been. But so let's try another one. So now it gives me a challenge. Okay, so what can I put in here so that when I cube root this, so it's 2 times something, so that'll give me a perfect cube. Okay, I know that a cube, like let's say if I want 2, right? So 2 times 2 times 2 is 8. So I want this to be 8. So you see, I'm like reverse engineering this. Well, what times 2 will give me an 8? Oh, well, this has to be a 4, right? So this would have to be a 4, because 4 times 2 would be 8. And we know that the cube root of 8 is 2. Okay, so now we know that this is going to be if x is 4, y is going to be 2. Right, so we're going to go 4 and 2. Okay, this is definitely not looking linear now, so that's good, because normally we would expect it to be up here if it was linear, but it's kind of curved down a little bit. And again, I could do the same thing with the negatives. If I put negatives in all of them, it would just end up being -4 and -2. So I'm going to write that in here. So sorry, go back. I'll go like this much. So this is going to be negative. If x is -4, it's just going to be -2. If you don't believe me, try it yourself. Right, so -4, -2, just like this. So I think I can draw it pretty okay. So I'm going to be like, okay, it's going to go through this way, curve, like, I'm going to try that one more time. Go through this way, it's going to curve. Something like that. It should look something like this. Eek. Those are not good, but the inflection point is like right here. I'm just saying. All right, so that's what the cubic's going to look like. So now the question is, what are my domain and ranges, right? So the domain in this case, so what can x be? Anything. There are no restrictions or anything like that. So could x be positive numbers? Could be a positive 1,000? Yeah, 1,000 cubed and divided by 2. Could it be negative 1,000? Yeah, negative 1,000 cubed divided by, yeah, we can do all that, right? So it's from negative infinity. So domain is going to be from, I can spell domain. Oh my goodness. It's going to be from negative infinity to positive infinity. The range is going to be from, well, what about the y? If x is a really big number, cube it and then divided by 2, it's still going to be a big number, right? So it's going to literally, this is going to be the same thing. And honestly, if you look at the graph, okay, you can't look at this particular graph, the inverse of this graph. So if you like flip it over, let's do that y thing, right? That's going to literally be what? Yeah, it slightly tilts up and slightly tilts right. There's all real numbers. Same thing with the inverse here. If you look here, yeah, x, and you notice that the arrows are going this way, which means x can be all real numbers. So if you literally say all real numbers, that works. Or you could just say from negative infinity to positive infinity. And then what about what is it called? Range? Yeah, same thing. So if you notice right here, the cubes are really easy. Cube roots are also pretty easy. There are no restrictions. It could be anything it wants to be. It don't even matter, right? This is like you guys. You could be whatever you want to be. Okay, maybe when you're 45, maybe not whatever you want to be, right? But there's some restrictions on that. But right now for you guys, yeah, you can be whatever you want to be. Enjoy it while you can. All right. Not to say that we should not pursue our dreams even at an old age. I'm just saying, not that 45 is an old age. I need to stop talking. All right. So if we take a look at here, this is the last 4 that we're going to do, and we're done. And so it says state the given function, state if the given functions are inverses. So just like how we did for the other review sheet, we're just going to put a function in a function and see if if all the operations cancel each other out until we just get nothing left but the x, then we're good. But we've got to check both of those. So let's try this. So we're going to try h of, and instead of h, we're going to put in f of x. Okay. So I'm going to set up my framework. So I'm going to write down h, copied exactly the way it's written, except whenever I see x, I'm going to put in the parentheses, because we're going to put in f of x in there. So whatever x is -3, divide that by 2. All right, and I said it was orange. So this is going to be 2x cubed plus 2. All right. And then now this is the fun part. See if we can cancel stuff out. Do I need these parentheses here? Technically, no, because they are not, what is it? There's nothing outside here that we need to distribute, right? This is just a regular -3 in the back. So yeah, I'm going to just take out the radical here. I mean, the parentheses here. And if you notice, ooh, we have this, what is it called? This 2 and the 3 that we can combine. So it's going to be 2x cubed minus 1 over 2. Now, I can't divide out the 2 completely because this goes in for the first term, but not the second term. So technically, I'm gonna just stop right here and be like, yeah, this is all I get. This is as simple as I get. And we're gonna be like, nope, no, they are not inverses. So once that inverses, what if it doesn't happen for one side, you don't even need to check the other one. It doesn't even matter at this point because it doesn't work for one side. So that makes our life just a little bit quicker and easier, right? But although I do like the inverse ones because, you know, I like canceling them out. So let's try this one. So we'll go f of g of n. And if you notice right here, I usually start with the top one and then I put in the bottom one. If you want to start the other way, that's perfectly fine. There's no like rule that says, oh, you have to do it a certain direction. Doesn't matter. This is just my habit, I guess. So f, I'm just going to copy down f exactly the way it's written. So when you see n, here's my parentheses, over 4. And now I'm going to input in the g of n, which is this guy. So negative 4n plus 4. Divide that by 3. And now this is where the fun begins. Do you see anything that I can cancel out? And don't say the 4's, right? Because we can't. Because the 4 has to, do you see how the bar is over the whole entire thing? The 4 has to go to both the first and the second term. Okay, it can't just go into one. Just like how we couldn't just put it in this one, but we couldn't put in the 1. Yeah, we can't just do that. So, I mean, if we want to separate it out, but we're not doing that either. So we're going to take out the 3's here. We're going to leave the minus there. I'm not dealing with the negatives yet. You can if you want to, but for me, I'm not doing that right now. And then, so once we cancel that out, what do we have left? I have 4 minus. And since I didn't deal with this minus, I still need the parentheses. And then it's going to be negative 4n plus 4. Note, I no longer have the fraction, so we're good. Divide that by 4. There's a lot of 4's going on here. So now I'm going to distribute that negative right here, or the minus. So that's going to be 4 plus 4n minus 4. Divide that by 4. And then the next thing to do, oh, look, 4 minus 4, that's just 0. Happy days. So it's going to give us a 4n over 4. What do you notice about the 4's? Now we can cancel the 4's because there's only one term here. And so that's going to be just n. Oh, look. This would be like, oh, we might have an inverse. We just got to check the other way. So let's do it the other way. So here we have our g of n. And what we're going to put inside is f of n. All right. And so I'm going to put in my framework of negative 4, parentheses, plus 4, divide that by 3. And I'm going to put in the f of n inside where the n was for the g, which is going to be 4 minus 3n over 4. All right, so let's see if we can do this. Yes, we can definitely cancel these out right here. Okay, and honestly, if you want to deal with the negative right now, we can be like, okay, if I just go like this, plus, negative, plus. And make everything the opposite of what it was because I'm distributing them out. That's how I normally would have done it if I was a student, just because I like shortcuts. That's up to you. Or you can do it how I did it here. Up to you about that. So it's going to be 4. Oh, I don't need a 4 anymore. So now I don't need the parentheses. I'm going to have negative 4 plus 3n plus 4 divided by 3. Now again, my negative 4 and plus 4 is 0. So all I have left is 3n over 3, which again is equal to just n. Happy days. So when this is true, when they both equal to n, not 3n, not n plus 1, not n plus 7, just n. Everything else canceled out except for n. Then you would say yes, they are inverses. Okay, somebody had asked me, like I said in the other video, what if these were the same, it equaled this, like this was like n plus 1 and this was also n plus 1. Are they inverses here? Always has to equal just the variable. Whatever variable you're using, that's what it has to equal to. So if you're using like x's, then it needs to equal up just to the x. If you're using n's, and it needs to equal up to just the n's, right? So that's what that's going to be. All right, so last 2 problems of the packet. Yay, we finally made it. Happy days. So, okay, well, this time I'll change it up. we'll do g of f of x. All right, just like that, just for you. I knew you were thinking about it. I don't know. Okay, so here's my framework here, and inside this x, I'm going to put in the f of x. So it's going to be x minus 1 over 3. And honestly, in here, I really don't mind fractions. I kind of like them because it allows me to cancel things out, right? Makes me really happy. So here, yes, we can cancel out these 3's. And what we have left, we have nothing else to distribute. So it's just going to be x minus 1 plus 1. You're like, oh, minus 1 plus 1? Those become zeros. So all we have left is x. So this looks good. Whew, so far so good. So we're going to be like, okay, let's try the other way now. We're going to go f of g of x. And let's set it up. So now I have my, whatever my x is, minus 1 over 3. And instead of my x, I'm going to put in g of x, which is 3x plus 1. Now, do I really need all these parentheses, this parentheses here? There's nothing outside here. So we could just write this as 3x plus 1 minus 1. Or if you want to just erase them, you could do that too. And notice, oh, yes, before we can cancel out the 3's, you have to notice, oh, yeah, these actually cancel out. Okay, got to get rid of all that first. Then we have 3x over 3, and the 3's cancel out, and all we have left is x. So yes, definitely these, yes, they are inverses. Our last one, let's find out. Oh, this looks interesting. I have a 5th root and a to the 5th power, so maybe these will cancel out, but I'm not sure about those numbers, right? So let's try these out. So f of, let's do blue, and this is going to be h of x. So what do we get here? So I got f, so 2. So honestly, you can decide what you want to put into what first, like what seems less complicated to you, right? Up to you. So f of, and then we got this x here, whatever this x is, minus 2 to the 5th power. And if you notice, I did the double parentheses because this already has parentheses. So the outside ones is the one that we already have, and the inside one just represents the x. All right, and so we have 4 plus the 5th root of 16x. Oh, this does not look pretty. Divided by 2. Okay, and if I look at this, I'm like, yeah, I could take out the parentheses because there's nothing in front of that. So, but it doesn't look promising. So 4 plus the 5th root of, what is it called? 16x over 2 minus 2 to the 5th power. I need all this in order to cancel this 5th root. I need like the 4 and the this divide by 2 and this 2 to cancel out. But yeah, it's not canceling out. It's not very nice. Do you see how the other ones were really nice and canceling out? And I mean, technically, I suppose you can say from here, I would just stop. But I suppose you could say, well, if we divide the 4 into the 2, I would just get 2. And then we would have just left the 5th root of 16x over 2, right? Minus 2, right? I mean, it could work. And then now I can go, oh, 2 minus 2, we can cancel that out. So then we would get 2 is, so these would cancel out. We would go the 5th root of 16x over 2. And if you notice right here, yeah, we could cancel these, the 5th root and the 5 out, but so it would be over 16x. But remember, we have this 2 to the 5th power, which is 2, 4, 8, 16, 32 over 32. Oh, wait, maybe it does work. What? Phew, good thing I checked. These sad days. All right. And then what do we do? So do you see how sometimes you just need to think it out loud? And oh, 2 times 16. Oh, yay. Because remember, that's multiply. So this is going to be 32x over 32, which is x. What? You thought we were done. Guess we're not. All right, so I'm going to put it in right in here. This is going to be where I'm going to put the other one because I don't have much room because I totally thought that that wasn't going to work out. But it did, so good thing I did that. I have to do this whole video again. No, don't want to do that. So here we go. So let's try the other way. So we're going to have h of like this and f of x inside. Let's see if I can even fit it in here. So h, I'm going to set this up. So I have my fraction bar. I have 4 plus the 5th root of 16x. So I guess this is what I get for judging an equation by its cover, right? Oh, well. So that's the 5th root of 60. Oh, instead of the x, we need to put in the parentheses, remember? We got parentheses like this. All right, and then we're going to put in the 2 on the bottom. And inside of the x, we're going to put in 2 minus 2 times x minus 2 to the 5th power. It's a lot of things going on here. Gotta do this slowly, step by step. So we got 4 plus. So let's look inside here. What can we, so remember this is just multiplying, right? So I could technically just multiply. I'm gonna do the 5th root right here like this. Multiply the 16 and the 2, which would be 32 times x minus 2 to the 5th power. And this is all, again, divided by 2. Okay, now we got to make this work. What is the 5th root of 32? Okay, we can try and do a thing, but remember, it's supposed to cancel out. So I have an inkling that this is probably a 5th root, a perfect fifth. So we're going to go 5th root of 32. So do you see how this works like this? 5th root of 32 and equals, yay, it just equals 2. That's it. So this is just going to be, this is now can go on the outside, right? Because that's just 2. And we just have the 5th root of 2 x minus 2 to the 5th power over 2. And you're like, well, technically we know that these cancel each other out too, right? They should cancel out because it's to the 5th power and the 5th root. So it's just going to be 4 plus 2 times x minus 2 over 2. I'm going to get rid of those parentheses. So 4 plus 2x minus 4. Remember, just distributing over 2. Now, okay, I can do this. So 2x over 2, which we get as x. We're like, what? Yeah, yep. Begrudgingly, I'm going to say, yes, they are inverses. Just like that. That's what happens when you judge a function by its cover. I'm just saying. All right, so that's the end of the review. Hope that was helpful. Skip through any part that you that you didn't need to see, and then just, well, hopefully you did on that. You just didn't come to the end here for, and you're like, I could have skipped. All right, I'll see you later. Bye.